Hi guys, this is going to be a demo of BLOAD and BSAVE and an AMS version of the same thing in RXB. So let's start off with this. The BLOAD command, what it does is it saves the lower 8K into an EA5 program, 32 sectors. As you can see, 32 sectors. And I created these screens with the BSAVE command. So let's show you what I'm doing here. Now, before we can do that, first we have to move VDP memory into the lower 8K because obviously it saves the lower 8K, it doesn't save VDP memory. So what we need to do is move, with my moves command, the RAM into video for the BLOAD, and for the BSAVE, it would be from video to RAM. So let's do a copy of this screen right here. Let's try it. We're going to call moves from video to RAM. We're going to move 2079 bytes. This is the entire VDP memory, all the sprites, all the character definitions, everything in VDP memory that we're using, up to the point where it just starts before it hits extended basic programs or any of the variables. Oddly enough, you could actually save all the variables with RXB and keep them, a copy of them if you want to with RXB. It actually allows you to copy the entire VDP memory if you wanted to in 2 pages of lower 8K because there's only 16K. Oddly enough, you could do that with RXB. You can do almost anything you can think of. Anyways, so we're going to move from 0, which is the screen image from 0, up to the 2079 bytes, which is all the VDP memory that we save all of our character definitions and everything like that, sprite motion, all that crap. Then we're going to move it into RAM at 8192, which is the lower 8K. Now what we're going to do is we're going to call BSAVE, disk, we'll say 4, and we're going to call the program, we're going to call the image btest. Now it's going to move all the memory in the lower 8K, then it made a file. So if we went to that disk 4, there he goes, our btest is right there. And it's 32 sectors as normal. So anyways, let's move it back. Let's go call clear. And let's go call BLOAD. Disk2 btest. That's the name. Then we're going to go, we have to move it from, now we've moved it to lower 8K, we have to move it onto the screen again. To the screen image table and all the definitions and everything. So what we do then is we go call moves. And this time we're going to move from RAM into VDP. And we're going to move 2079 bytes again. And we're going to move from 8192, which is the lower 8K, into 0, the screen. And we get an error. Why is that? Because I used disk 2. Whenever I make a video, I start to get a little nervous. Sorry, guys. Silly mistakes. 2079, 8192, 0. There you go. So we could do the same thing with all the VDP memory at once. And that's where we get into this, the demo. Now what it's going to do is it's going to BLOAD one of these screens, and then what it's going to do is going to move it on the VDP from RAM into VDP memory like we did. Then we're going to start a loop of doing that each time, and it looks like I'm missing a line down here at 165 or 160. Yeah, 165 is what it looks like. I'm missing a line. Call BLOAD 1 SCRN, and then we're going to put S string. And we're going to make it A, which is the variable. And that should fix the problem. If we run the program, it's going to load each one of these BLOAD screens over here, one at a time. Let's just keep looping doing that. That's all it's going to do. Now, as you can see, it loads a screen much faster than you could draw one with Extended Basic, because you have to go in and you have to find all the definitions and everything and load them one at a time. This loads the entire VDP memory at once, so it's in one shot. And so it's much quicker. Anyways, that in mind, let's load the other program, which is the MS demo. So if we go old disk 1 AMS LDR demo. Whoops. Here's the loader. The only difference that I've added to this is the AMS. What it does is the call AMS in it, sets up the AMS. It uses the same thing, but it adds in this line right here. And that line is to switch the banks. So we're going to put, first bank is going to be A, and we're going to add 20 to it, which is 20 up, because there's 20 screens, and it takes two 4K pages to make one lower 8K. So we have to do an increment of 20. We could do +1 and then switch forward by stepping 2 each time. Same thing. Then what we're going to do down here is complete the demo down here and just rotate through all the screens. So let's watch what it does. It's going to be slower the first time through because it's loading off disk. The second time through, it's going to start using the AMS memory card instead of loading it off the screen, which is going to be much quicker because, of course, memory is always faster than disk. But it is pretty fast even off the disk, as you can see. And I think it saves a lot of space. The amount of program space you'd need to run this program the other way would be considerable, to say the least. So as you can see, AMS is much quicker. I think this is a pretty good demo for the advantages of the AMS combined with BLOAD. Now, think for a moment, you can load assembly language the same way. 1 meg of assembly language support for one extended basic program. Almost anything you can imagine you want to do with extended basic you could do. Combined with my user in RXB, there's not really a limit to how many, the only limit you have is file size, and with the Classic 99 you don't even have that. So anyways, I just wanted to point this out as a demo, and we will talk to you guys later the next time I come up with an idea.